Hi, welcome
Great.
to Real Qadam podcast. And today we have special guest Jamin Hu, co-founder and CTO of DoublePoint, a touch interface company. He's also a graduate from Imperial as a biomedical engineer, but not only is he a graduate of engineering, but he's also a graduate of classical piano from University of Arts Helsinki. I got to know Jamin through my friend Anne, with whom we had previous podcasts. Jamin is someone who is not just a strong engineer, but also creative thinker, and described by his co-founder as someone who lives in the futures and sees the future. And we are very glad to have you here, Jamin. Thank you for coming.
Thanks for being here. Yeah, I'm not. Uh, yes, those are high words, high praise. So, but yes, nice to be here.
Cool. Real Qadam from Kazakh translates as real step. And the traditional question that we ask from guests is what is the real step or consistent steps that you have made in your life that made Jamin, who is right here, who that shaped your identity?
Right. By the way, also, I already I love the first question already, and at any point, I usually take a little bit of time to think before I answer. But if you would prefer, it's also totally fine to expect sort of whatever's on the top of my mind before I go into like minutes of just thinking by myself. So just tell me when um, what sort of a answer you prefer. But I think um, for me, I'm not actually sure how much of my choices were a conscious, deliberate step, and how consistent they really were. What I noticed to be the most consistent is a um, a curiosity for how things work uh, at a level that might like bother others sometimes, my teachers, my friends, and things like that. So I think whether or not it's piano or the sciences, I think mainly in the sciences, um, I've uh, I've spent a bit longer time than usual trying to understand the root cause of things or why certain things are a certain way, and I think it's easier to answer those questions in science, and so I've been gravitated towards science. But yeah, so I think maybe that's one overarching thing. Uh, there's plenty that I think I need to improve on in terms of my discipline and consistent steps. But I think that's one thing that's sort of tended to happen is my questioning of how things work.
Mhm. How does it manifest in your daily life right now? The curiosity.
Yeah, sure. So maybe one clarification also to do here. I have like half a year left until I graduate from Imperial, so fingers crossed that your statement will be true that I'm a graduate. But so in school, a lot of the times I sacrifice my grades in order to understand a specific more deeply, and so it's impossible to understand every topic deeply. So I have to choose which one to work on deeply, but a lot of it is not like examined or tested. So basically, you can see it in my grades, for example. Uh, like on some exams, I do extremely well, and on some I do like I pretty much fail. Um, and then at work, I think I spend a lot of time almost sort of philosophizing about things, like why we're doing the startup in the first place. I think I question the existence of the startup the most, at least from what I know, at least in this company. So that's why I think Otto, that my CEO, co-founder, says that I'm a future thinker because I try to, I don't know, I think that's kind of related. But yeah, I actually think probably to him it looks like I'm a futuristic visionary, but actually I'm just very self-critical about anything that I do, and so it's more like self-doubt. It's more like a manifestation of self-doubt rather than a visionary scientific intellect. But yes, manifestations in different ways.
And about that, like, were you questioning because of like you don't really want to go into different direction rather than like where you want to end up, or it's because of the nature of stuff, like you don't want to do what you don't really enthusiastic about, like what's that about usually?
Two ways of looking at it is that one, it definitely is not obvious that a startup is the way to solve certain problems in the world. There are
Mhm.
certain things that are well suited for startups. I think, like when I was in high school, I wanted to do a startup for the sake of it. But then like, and I had so many ideas. I was like, oh, the world could be this way, and oh, I could make it like that. Uh, but then I feel like, especially with this is my first startup, so my first uh, real exercise at this. So many times where I'm like, yeah, this is not like a big company could do this much better, or even a nonprofit or a government. This is not really the job for a startup, like a profit-seeking startup. And so that's one thing. And then the other thing is, I think maybe it's been hammered into me since I was a kid, but there's a lot of motivation to be either special or the best at something. Like that's still in the back of my mind somewhere, like unconsciously, as much as I'd like to sort of rid myself of things like that at times. But so I think that acts has an effect. So I ask whether or not me doing what I'm doing now can bring me to becoming the best at it. Like, is it something that I can be the best at, or our team can be the best at? And so to answer the question, um, sort of where does this questioning in the company come from? I think it's these two. So I'm not even sure if we should, like, it's not obvious that we should exist as a startup. And second, um, do we have a chance to be the best at something? Uh, if that answers your question.
Yep.
Mhm.
In the world,
Yes.
Jamin, where you have also mentioned the story about like your university, how there is a lot of standardized tests, right? Examinations that assess you and that objectively compare you to others. And like the fact that we also were raised in the environment potentially where being the best was kind of um, a thing to strive for, right? Ho- to what extent do you think um, curiosity dies in those kind of spaces? Because it feels like curiosity is something that comes from within, and I have watched some video where they're like all kids are like geniuses, very curious
Sure,
and
sure.
ask questions, and
Yeah.
as they go older, because of some standardized boxes and stuff, people become less curious. um, how do you balance the world that asks you to be objectively good based on certain metrics, right? And still maintain this almost childish curiosity that also brings some sort of geniuses, right, to this world, like some sort of genius inventions, right? Something that is not unusual, not just a status quo or small incremental improvement, but something that is actually a big change.
I definitely don't have a sort of strong answer I can advocate for here. And maybe if my startup was in this field, I like was trying to tackle this question, then I could answer a bit better. But I know that on my side, mm, first of all, I'm not exactly sure if the curiosity in children just naturally is a phase, like just it's meant to really like when the brain's developing. I don't know how the neuroscience works, but it's not completely obvious to me that curiosity is supposed to stay for your entire life, even without outside influences of like school. I'd like to believe also, of course, that it's school that is like the system that is making me and the people around me less curious. But perhaps, yeah, it's not obvious to me. But the reason why I can see that, or I can see school having an effect, is because I do see that uh, uh, a lot of classmates that go through school, much more often they prioritize grades than not, than just like trying to really deeply understand something. If deeply understanding something serves you to get good grades, then they'll do it. But mm, Other than that, not that often. And I think that has to do with, to answer your question of like, how do you maintain the curiosity? I think one thing that school sort of biases you to think of is that uh, like that others define what best means. Like for most of your life, I think others have defined what best means, uh, whether it's school or your parents or I don't know, your teachers or something. But I think that is completely not a given in life. And at some point, at least in the startup, I think the first thing that I noticed in the first year or two is that there's no one to tell you what is best. So you have to do the thinking and philosophizing to think of what really best means and then define that for yourself. Um, and so I think that would help. That might help your pursuit in your intellectual curiosities because then you know that there's not one outside defined metric for best, but that best can be what you have defined as deep understanding yourself. So maybe to summarize my answer, I'd say that uh, I can see people going through the education system uh, putting their curiosities aside in favor of grades, but only because their targets are well defined and best is well defined. Being the best is well defined there. But if best was defined uh, by themselves, it might be a different situation, perhaps. That's my take, current take at least.
Yeah,
Are my
yeah,
answers
I'm
too long, by the way? Would you prefer this level of depth, or would you prefer something more concise?
Uh,
whatever works for you. I think like whatever like
Sure.
you think
Okay,
is
cool,
great.
cool.
Yeah. And basically
Great.
following up on this, I'm wondering if like this like goal of being the best really was relevant also to your experience as like uh, being the professional pianist, right? If I can
hundred
tell
percent.
like this.
It's definitely. I think there's a lot that comes from there, which is a little bit counterintuitive since pianism is or it's an art. And what does it even mean to be the best at art? And then there are these piano competitions which are meant to rate how good you are as an artist. I don't know what that really means, but it has had an effect. Like I've had to go to a lot of piano competitions and being the best was kind of ingrained in me through that as well. So
Yeah, because like I'm not really close to that like sphere of like the art
sure.
and the music, but I really,
Yeah,
really
yeah.
like maybe from movies and like from acquaintances who really also went to music
Yes.
schools or stuff. They're really like competitive and like it's always right. You're kind of growing up with
Yes.
those competitions and like a professional
Yeah.
approach to stuff. And I think yeah, I really like
Yeah.
had this impression that the people who really finish and graduate from those schools are like really competitive and want to be best at that stuff. And yeah,
Yeah, yeah. That's part of it. Of course, I know many people that are very competitive without the, I don't know, extracurricular sports or arts in their life. But
what's the story behind your uh, classical piano degree and your biomedical, then changing to biomedical? Not really
sure, sure,
changing,
sure.
but starting biomedical engineering journey.
Yeah, of course, of course. So classical piano started when I was 4, and so I don't have any memories of even like not playing the piano because the piano was always in my life since I was a kid, and it was mainly my parents, as it very often is, sort of trying to set some foundation going for me at an early age. And so piano entered my life thanks to my parents. I think it stayed in my life like beyond my teenage years. Well, actually, because of the path that I was set on, but also because later on I started to find my own like interest in music as a whole, and especially at music university, I got to like I think in music university I properly felt like a musician because before that I was exclusively very piano focused, piano, like music theory, music history, and other genres didn't interest me. But then at music university there were so many to choose from, and I really felt like oh, this is you know um, what it's like to be an artist. But then at the same time, my science was always part of my life as well, and I was like, Brexit is probably happening, and I still can rely on my grades to apply to universities. I've had a taste of um, music already, so perhaps it's time to try something. And then I tried to apply for English universities because my education was mainly in English. And then um, I applied for a few places, and biomedical engineering was the one that eventually sort of where the degree and the university was uh, good enough to my standards, but also where my interest aligned, and also I got accepted. So um, yeah, I didn't want to try applying too many times. So for example, I would have like electrical engineering would have been an option as well. That would have been very interesting, and so would have general engineering. Uh, but yeah, biomedical engineering I got into, and it was good. I was interested in it, so yeah.
Makes sense.
I think the most interesting part about you, for me personally, is your startup. But before we start this topic, I think it's interesting how did startups come into your life? How do you come up with this dream of maybe building startup, and after bioengineering and piano, how this all happened?
I think a startup for me is just an extension of any personal project of mine, but but I've been doing like science side projects on my free time all the time, very heavily inspired by a lot of science YouTube channels like Veritasium, Smarter Every Day, and SciShow. I remember when I was in high school, there was a moment where like I haven't met this one friend for a year, but then I'd been watching SciShow for a long time, and Hank Green is the host, and then she noticed that, or she told me that, hey, you're starting to sound like Hank Green. Are you okay? And like, are you spending too much time on YouTube? Um, but yeah, so I saw videos, and then I wanted to do some projects myself, and I had a YouTube channel at some point as well. I was so into that, and then. Mm, so yeah, I've been doing projects for a while. I think like, this startup was the first project um, where Otto, who's much more business oriented, and I really love him for that. Um, where he and I, when we discussed, and when we discussed with our connections that we knew. This was the first startup that project that looked like it could be VC funded and that we could scale into a meaningful company. Uh, and the timing was right, and a lot of things sort of came into place. So it wasn't like one day I decided, I need to do a startup now, so I'm gonna fucking do it. But it was more like um, Otto was always aware of the projects I was doing, and then this one, the right time and place came to be, and then we were like, you know what, let's make this real and see how far we can go with it. So
One thing that you mentioned is this startup, in general, this side project, right, as it started, uh, was VC fundable. I guess for our listeners who are also interested in entrepreneurship journey, who are also doing some sort of side projects, what are some signals or variables that can make a good case for VC fundable story rather than just a side project?
right, so the data point that I can offer here is that the prototype I had was pretty much a wristband that could detect which fingers was twitching. And so I could, for example, type in the air. So I could type thoughts as fast as I sort of had to practice at some point in my life 10 finger typing, so touch typing, so I could type really fast and I didn't have to look at the keyboard. And so the wristband itself could do that and was made really quickly by pretty much me only. And then the software part of it was done by, well, a few friends. And when we showed this to an investor who was a connection of Otto's, he pointed out that the thing that we were trying to do has taken some other teams in the world a lot more effort to accomplish, and we were doing something that had the chance to basically compete with that with very little, with much less effort and just sort of the right approach. So I think this was where it gave us hope to get started. um, where you see that, at least for me, I saw that we could achieve something that took millions, hundreds of, actually hundreds of millions, for another company, but we were achieving some similar demos, not the entire, like we weren't matching full on, but some similar key milestones, with just a few people, a few students, basically. So yeah, that was one key indicator that it was VC fundable. So
Cool. So like if the story or the project that you're creating is able to reduce the time and investment significantly, it means there is some unfair advantage, right? Where which you can use to potentially start an exponential story, right? Because
yes,
essentially
that
like
unfair advantage is uh, yes, is how I would put it.
amazing. Cool.
No, you were going to say something again.
No, I think it will just summarize it.
Right, sure.
And so like you mentioned your prototype, but can you just explain what is this like double point technology startup about?
Definitely, of course. So, we call ourselves a touch interface company, and that is a more sort of abstract ideal of ours, that we think good interactions are based on the sense of touch. So being able to detect exactly when and where you touch things, and that's like a universal human thing that's been around for ages. And so any good interaction has that. So if we want good interactions for next, computing platforms, we need to detect touch, just as well as we've had with touch screens and mice and keyboards. And they're all basically very tactile things. So that's the high level thing. Right now, our first sort of approach to that is actually just creating gesture detection algorithms for existing smartwatches that can detect then touch. So for example, just this when you pinch your fingers together and the exact moment that your index touches your thumb, that's that's something that, if we can detect, it would make interactions extremely comfortable and intuitive, and and so we're trying right now to do that just with the IMU and the PPG and potentially other sensors on existing smartwatches. The reason for that is because, I think our hypothesis is that the the effort and scalability is extremely worth the interaction fidelity that comes out of this algorithm. So just with this like pinch gesture, you can do a lot of things better than our competition. We basically want to detect touch, and we want to do it as efficiently as possible. And right now, our first step is to do it by a software update onto smartwatches.
Can we be a bit more, sorry, can we, you started talking about watches and the sensors. I'm curious
Yeah.
about like technical details. What are the watches and what are the sensors? Also, like, could you explain what each sensor does for our listener and what this abbreviation stand for?
Yeah, totally. Maybe also to give context, like where are these interactions actually used? Just I'll give two examples. One is that, you can point your hands, like just with a smartwatch, just with the smartwatch sensors that like on your own Apple Watch or Samsung Watch, you can point in any direction and the watch would know where you're pointing, and then you can tap your fingers to select it. So now you have a general purpose point and select device that's always on you, and has been for a while. So you don't need, for example, cameras to always be videoing your hands and then figure out what their hand shape is and then try to do it. No, it's just a very low power algorithm on your smartwatch. And then the second is that you can pair it with eye tracking so that you just look at what you want to select and then tap your fingers to select it. So this is even faster and more intuitive to learn than the computer mouse was. I mean, I'm sure most people remember some figment of when you had to use the mouse for the first time, and it wasn't completely intuitive. It wasn't complete. You had to get used to how the motions changed, like the cursor's motions changed according to your hand. It wasn't a one-to-one necessarily, and and so here, your eyes naturally look at a lot of things that you want to select before you select it. So you just look at it and you tap it. And your hand can be behind your back. It doesn't need to be in front of a camera again, because that's what currently needs to happen. You either have to have cameras on your headset, on like an AR headset that's tracking your hands, or you need like a webcam of sorts to track your hands, which just isn't natural to keep your hands up here all the time. So that's why this is important. These are the interactions that are extremely useful and easy to learn and are possible with this low power smartwatch algorithm. And now to answer the question of the algorithms, sort of what sensors the algorithms use. So the IMU and the PPG are the two sensors that we focus on right now. The IMU stands for Inertial Measurement Unit. It measures basically the acceleration and rotation of any device that is attached to. And so it's the same sensor that is, detecting whether your phone's in landscape mode or portrait mode, and also detecting the step counts, because when you walk, your phone detects those vibrations as steps. So that's the IMU, and it's in pretty much every smartwatch. And then the second one is the PPG, which stands for photoplethysmography, I believe. Oh my God, now I need to check. It would be embarrassing if I didn't. Yes, photoplethysmography. Yes, exactly. And it basically measures your heart rate. So, and the way it does that is that it just shines a red light onto your skin, and then it measures how much red light comes back. It can be red, it can be green, it could be infrared. But most of the time, for whatever reason, whenever your heart pumps blood once, the amount of red light that reflects back just slightly changes every time your heart beats. Whether it's because the capillaries slightly expand, or maybe the oxygen is more red when it's oxygenated, or because, so for whatever combination of reasons, it's just your skin is more red, and so it faces your skin, and that's usually what it's used for. But we sort of repurpose that signal to detect gestures. So as you move your hand around, as you sort of do this pinching gesture, the redness also changes, but in a different way. And so we repurpose that and use it to detect, to create this algorithm.
Sense. And how are you able to build in a faster way? Is it essentially some ML classifier that you have?
Sure. All right. So what I think is important to note here is that our first prototype is pretty different from this prototype. Yeah, our first prototype was actually supposed to compete with EMG, and now that's another acronym. EMG stands for electromyography. It detects the muscle activation wherever you put the sensor, and one would imagine that, hey, if you want to detect gestures, why not just detect how much you're activating the muscles to do those gestures? But the hard part about that is that your muscles are actually that detect the gesture, or the muscles that activate that move the gestures are placed really sort of widely across a lot of different locations on your hand. Like, for example, the thumb. To move your thumb, there are muscles that are on the palm itself, which aren't even in the wrist or in the forearm. So if you want a sensor there, you have to wear a glove, and that's like sort of not socially acceptable. Our initial prototype was meant to compete with that and show that actually you could have also photo like a photodiode and phototransistor based sensors on the wrist to look at how the wrist contour changes as you move your hand. So all the information that we're detecting isn't on the muscles or anything, but it's at the wrist where the tendons sort of go through. And maybe if I shine the light correctly, you can kind of see that everyone's wrists sort of changes shapes here. And even if you can't see it with your own eyes, it's there, and it can be detected with the sensor. So we use this technique, and it worked surprisingly well. So that was what was fast, because these sensors are very cheap. They're very robust. They, like, literally the first like, you don't need to engineer fancy electrodes with fancy materials or have like high quality signal amplifiers or anything. You have a photodiode, very cheap photodiode, and yeah, a lot of aspects of it were robust. So that's the first prototype. And then we realized that actually that didn't directly detect touch, but it detected sort of much you're sort of trying to move, and that's slightly different. What we really want is to detect just the touch, like only when a touch actually happens. So, for example, if let's say, sometimes when I touch my fingers together, I can do it two ways. I can either just relax my fingers and then it goes down. Now, relaxing the fingers won't look like anything here. It'll look like you're relaxing, but another way of pinching my fingers is to actually like squeeze, and that'll look different on the wrist. But we want both of them to actually be detected as the same thing. And so detecting tendons or detecting muscle movement wasn't really going to be accurate enough. It wasn't going to be sort of relevant enough of an interaction. And that's why we were thinking, okay, we need to actually detect the moment of touch itself. And the smartwatch sensor that was really relevant for that was the vibration sensor. So the IMU, which detects basically vibrations, the IMU detected vibrations, and vibrations only occur when touches happen. So um, that was when we realized, okay, if we want to detect touch, and that's important for interactions, then we need some other sensor, and let's just start at looking at what already exists out there, and that was the smartwatch and the IMU and the PPG. And now we have an algorithm that's we haven't found a better algorithm to detect touch than this on smartwatches, at least. So
I imagine, how much biology do you need to know basically to kind of at least come up with some of these sort of I don't know, like the decisions, or like understanding basically how does it happen, or it's just matter of like you did know that you can do it and then you just researched it.
I think first you need to believe, or you need to sort of figure out how important, like what is exactly the thing you need to detect. And for a while, we didn't really know it was touch. But after thinking and experimenting a bit, like what makes good interaction? That's something you like after you spend enough time on, and you're like, you come with some answer of your own. That then that's a great guiding principle. So that took a while. Um, I think it just took experiments and actual like thinking. Some even some like maybe some basic biology and some maybe some design thinking and actually maybe even some philosophy. But anyway, so that's that. And then to actually know how to sense it, yeah. So you can do it two ways. So we've done it the way where a lot of us were machine learning engineers. So we could use data science to try to answer, what sensors can detect what. We basically followed that approach. Another approach would be, and it's an equally valid approach, is to actually understand the phenomenon of what happens when you touch your fingers together. So how are the vibrations transmitted through the hand? Like how much does the hand dampen the signal of this touch? What environmental factors affect the vibrations that travel through the hand? What's the frequency response of the signal, and things like that. So those are all things that over time we started developing an understanding for, but we started off by treating it as a data science problem, so not necessarily physiology or biology or physics problem.
So I have two questions here on the more technical aspect of the startup.
Sure,
the first question is, I've noticed there is a big premise or like an assumption for the product that you're trying to build, which is a particular type of touch, which is pinching one finger, like pinching your thumb and your first finger, like pointing finger together as a way of selecting. I'm curious to which extent this premise is valid, and why are you guys going towards that? And like, there's so many more actions that we do, and actually the way we select is hand grab usually, right? Like we take stuff. Why is it like this type of action? Because I've noticed the same pattern with Apple OS advertisements and stuff. And I'm curious why people are coming up with this interface. And then I'll ask a second question, which is more related towards data science.
I think most of the people in the world tackling this problem now are operating on working hypotheses. So not necessarily like things that have been thoroughly empirically tested. Perhaps Apple has the resources to do that, But so our working hypothesis is based on the assumption that most interactions need to be very low effort, like extremely low effort. Like just how many joules does it take to perform that action? So that's one. Uh, Second, where has this action occurred in human history most of the time? Like, for example, a very low action gesture is like your eyes blinking, or a low joule count. But we never really do anything with eye blinks. It's just to moisturize your eyes or something. So so yeah, so I think these two things are very important. Uh, and because if you take these two into account, so low effort and how much we're used to it, then there's a much narrower like set of things that you can select from. And yes, so I would say that is the best. Like these are the two most important factors deciding why this is going to be universal. Uh, we can also detect this. For example, we can detect other things, but this is sort of the lowest effort way of like selecting things. Um, I don't think it'll be the only way. Definitely not the only way. But you know, just how like the mouse has a single click button for most interactions. I think this is the highest likelihood interaction for such a sort of such a thing in AR and future interfaces. So, yeah, if that answers your question.
A small question here related to that. So if we kind of think about mouse, there is like actually two buttons, right? There is a select button and the right button, which
Yes.
usually opens your like a menu or something.
Yes.
And it
Yes.
usually the right button's function is that it just makes user interfaces are much more simpler. And when I think about like the hands, I think the future user interfaces could be much more simpler. So there will be no like close buttons. So you don't have to
Right.
select on like touch on the close button with a pinch. It could be
Yeah.
like any other gesture or
Totally.
something like that. So there will be really easy user interfaces where you can do a lot of stuff like a Spider-Man movie when he was trying different
Yes.
stuff to shoot
Yes,
the yeah. And what did you think about, like, do you guys think about other kind of gestures or do you think about simplifying the user interfaces so it could be much more simpler to look at?
I think there's also some other element of your
Like,
approach
why are you
that
building the startup? Which, like, I mean, not why are you building, but for me it feels like you're making a startup about selecting items or something. Like you making the
Yes.
mouse, but with your hand, whereas in
Yes.
mouse is very limited with two buttons, and like scroll.
Yes.
But while the hand has a lot of different moves and like
Exactly.
gestures.
Why does the mouse only have one button or two, like one and a half, because the other button is rarely used? I would say 20% of the time, or maybe more, maybe less. So why does the mouse only have one button? Why doesn't the mouse? I mean, the mouse actually some mice have a lot of buttons, right? But how often do you see that in the world?
Just to continue your thoughts, there was like already were like one evolution, right? Already like from mouse to touch screen, which sort of also had almost one action only, right? You can click, or at most you can also
Yeah, with multi-touch you have like two fingers. You can input with two fingers, but still it's just really two or three. So like dimensionality of inputs is still not that big. But then like, and still it's just part of my first thought. Right click is mostly prevalent because it's learnable quickly and everyone's used to it. But it takes a lot of time to remember what the other buttons do, like on a fancy mouse. Maybe gamers can, maybe designers and power users can, but like it's non-trivial to design higher dimensionality of inputs that have zero learning curve. I'm trying to think of an example of high dimensionality input that humans have designed where the learning curve is zero, and I can't come up with any. Maybe, and first that comes to mind is a keyboard has so many buttons, but oh my God, how long? Like most people still don't know how to use a keyboard quickly enough. So there's this sort of, and I do agree that with high dimensionality, you can actually reduce the visual clutter on the screen because a lot of it is sort of invisibly mapped to those to the multiple input dimensions that you have. But I think that's probably maybe that might even be part of the problem where you don't see what you can do. And a lot of user interfaces, or this whole idea of graphical user interfaces and the WYSIWYG, so what you see is what you get, is that any new thing that is designed, the user can instantly see what their next actions will cause and subsequent actions and all their possibilities. So they can see it. They don't have to learn it or memorize, or I guess a long way of saying, this is just all a long way of saying that it isn't obvious to me that higher dimensionality is going to be more usable. I think it can be if the interactions and the actual inputs are intuitive. So for example, I don't know, closing a window probably will just be like taking something and throw it away or something like that. I don't know. Or maybe it's like this gesture, like just go away or something. Maybe like things like that might be good, but yes. And then I think the second part is just to address that I think there is definitely room to develop more gestures than just this. There's a very common gesture that we use nowadays, which is like scrolling. And scrolling basically is just like it's continuously, changing the touch position on something, whether or not it's a touch screen or it's a scroll wheel on the mouse, and it's so you can't really do it with just a tap. Like right now to scroll, you have to like tap and you have to drag upwards, and that's you got to use your like shoulder and stuff, and that's like the joules are orders of magnitude higher than something like just this, right? So of course the ideal would be that we could. This would be one example of an intuitive, higher dimensionality interaction that we are trying to do. So. One of the holy grails of the interaction as a whole is these sort of micro gestures, and they're called micro gestures in case your audience is interested in. And our products are or a lot of our development efforts is going towards that. So trying to do this, and if not this directly, just if it's not directly trying to do the most ambitious, like continuously scrolling on your finger to like act as a touch screen. We're starting with small steps. So for example, just having buttons or like having these motions mapped to left, right, up, and down buttons, so that you can at least have some like left, right, up, down situation going on. Which I mean, the arrow keys are used at times for things. Still not as used as the mouse and the click, but definitely more easy to use. Like arrow keys are more easy to use than the rest of the keyboard, at least. So yes, I hope that answers the question. I think this is exactly the sort of questions that we had to spend a lot of time thinking. Like, is high dimensionality important? A lot of people, Elon Musk is fucking putting electrodes in brains because of higher dimensionality input and output he wants. So there's something important about that. But yes, how much does it apply to augmented reality? I'm not sure. So yeah, but thanks for asking. That's great. This is exactly what I love talking about and thinking about.
I think we'll definitely come back to future of computing and have more frameworks of thinking. I think you already have some sort of systematic of thinking about like dimensionality and certain actions, right? We can talk about it a bit later. I think I want to turn back into DoublePoint, the startup that you're working right now. And before we go into business section, I personally really am curious more about like tech there, and in particular the way you said that you are looking at it as a more data science and ML problem. Basically, like I assume it's some sort of classification after you have a lot of data. Yes. But working with a lot of classification algorithms that are especially neural network heavy, they need a lot of training data, right? Yeah. And I'm just curious, given that you are a startup, I assume you don't have a lot of clients initially, especially. How did you develop first prototype that is generic enough to detect how majority of people do the click event? And how did you approach the data science part of like more of like augmented reality problem, right? Like where there is no even open source data set that you can use.
Yeah, definitely. So we had to make our own, and that's one of the hardest things. So mm, that's one of the hardest things, and it's one of the things that also keeps us competitive. So knowing, like, not everyone immediately knows, or it's definitely non-trivial to know exactly how much data from who in what situations, uh, and does it take to make a generalizable model. And I think at some point in this company, I would be happy to share that in as much detail as possible. But right now, I think this is exactly one of the things which is a competitive edge, and I'd probably if possible, I wouldn't talk too much about it. But it is a very important it's a very important question, and it has taken a lot of time and effort from us to figure it out. I'm not saying we've fully figured it out, but it's like when you learn data science, I haven't seen any, or not. Okay, actually, I personally have not seen any data science course, that teaches you what data is important to collect. Like, I don't know, maybe you guys have, and if you have, please tell me, because I want to sort of benchmark against that. But even in like the Bible of neural networks or something, of deep learning, literally the book called Deep Learning, right? By who was it by? By no, Ian Goodfellow, of course, Joshua Bengio, yes, Bengio, yes. Okay, so there's literally, I think there's one page in that book that says that tries to answer the question, how do you know if you need more data, or how do you know what data to collect? It's literally one page, and I can probably send it to you at some point. But this is yeah. So it's been the hard part, and it's taken some time.
Yeah, interesting. So it's not like a lot of fancy ML algorithms that people talk. Like I think that's what a main misconception about like being an ML engineer, or like amazing data scientist. Everyone romanticizes the part about building difficult architectures, and like especially giving like transformer architecture that is popping up. Like it doesn't really matter, right? Like as long as you have enough and good data in a good format, like even like trivial, just simple neural networks will have a good better than baseline algorithms, right?
Yeah. So I do think a lot of that is true in a lot of data science challenges. I think it's especially true in our situation, especially because our models are not, like, they don't require data centers filled with GPUs to train. Um, so 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 the model sizes aren't big enough where sophisticated uh, neural network structures become important. Or at least that's the assumption here, that sophisticated architectures become more important when the model sizes are big. Um, so so of course it's not. I can't say that our our neural network is not just a fully connected. I mean, it's so I don't actually think it's that bad if it's even just fully connected. But the point is that yeah, the a lot of effort needs to go into data collection side of things instead of the model engineering side. Uh, yeah.
Mhm. So coming back to your technology that you are doing. So like one point that I had to add about what we've just discussed about, like basically mimicking what mouse does, right? So I think like those pinches, what you detect, that's probably just like the tip of the iceberg, right? Like that's kind of
Sure.
showcasing what you probably can do, and then if you need all the other touches, you'll probably be able to do it. Like you have assumption that if you have prototype this, you can then prototype this, and all other stuff that you can
Yes.
do basically with your hand, right? So
Sure.
then coming back to what like you're doing as a business, right? Because like if you do research, non-profit, you can do like a lot of that stuff and basically publishing it for all the people to like use and maybe research all in different directions, right? And I'm wondering like from business perspective, so like you're not selling, but yeah, correct me if I'm wrong, but like
Yeah, sure.
my assumption is that like you're not selling some specific product, like just API for identifying the pinches, right? Like your technology can do better, like can do more, right? And can you tell like what are you really selling? Are you really like this like
Absolutely.
a level of like based like your technology that every like other developer can use, or like you are selling it to the hardware manufacturing companies to introduce like intrude into their like devices, or like yeah, can you tell me
Of
about
course.
that more?
Definitely. So the core technology is, in the end, the algorithm which takes the sensors as IMU and PPG and then outputs the gestures. That actually is the core technology. So um, that's the part that it's been relatively hard to replicate well enough. Uh, and second, that on its own can solve a lot of problems in for example AR, and I can go into that a little bit soon. But so that being the core technology, we actually do pretty much we license to businesses that need this algorithm. Um, and so, I mean, that's the first step. And in the end, I mean, yeah, actually, even now, the algorithm itself does not only the selection, but it does, uh, the state of the pinch. So you know how long you've been pressing for. So you can do long presses for a right click, or you can do the, pinch and drag, and then you can do these sorts of interactions. And we hope that very soon we can do left, right, up, and down, which also increases the usability of things. And so that this sort of gesture detection algorithm is what we license to businesses. And the Wow Mouse app that we have on the Play Store, that's just for people to try and play around with and to just get some feedback from consumers on how they use it. But in the end, the business model is licensing our algorithm. We also then license a reference design for example, headset manufacturers uh, that want to make a simple bracelet that can run this algorithm, but have never made, bracelets or wristbands before. And we tell them, hey, here's the components you'll need, here's the compute, the battery life, the form factor, and on top of that, here's our algorithm. And yeah, so that's sort of the business model. And the reason that we um, the reason that they would actually buy this is that, so first, who are the customers really, and like what's the sort of critical problem it solves for them? So the customers here are literally headset manufacturers that are trying to make light all day, AR glasses that look like everyday glasses, sort of like the Ray-Ban stories too, like where you have like only two cameras. It does very basic functionality. There's no even display, but in the future, hopefully, these AR glasses will have displays. And the problem here, and everyone knows this, is that like whenever you move into such a small form factor on your face, the battery life and the compute it's very precious. So you can't really do all the hand tracking and the 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 the, the stuff that a Quest can do, like with cameras. You can't even fit that many cameras on it. You and um, so they need a way to track the most important gestures without making the battery life just like 20 minutes, without reducing the battery life too much. And right now, the only solution they have is either like a sort of remote control sort of puck situation that you can hold, or using your smartphone, which I think is just backwards. Like the point of having glasses is that you don't need to pick out your phone. Um, or you use voice, which is what the Ray-Ban Stories currently uses. Um, but voice has its limitations. I don't like no one's gonna use it all the time everywhere until like AIs get really 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 good. Um, at least that's our hypothesis. So basically they need another alternative, and this is where we come in and we say just do the interactions on the wristband, use our algorithm, and your headset's battery life can dramatically increase. So yes, that's where it actually makes the most sense. And ideally, we started this company spending like a lot of time thinking what's the ideal interactions in the future, what's like the 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 future that I would want to live in, and it involves way more complicated gestures than what I described. Like ideally, I could detect when and where I'm touching anything, not just my fingertip, but like on table surfaces, on phones. Actually, you know what? A phone in the future could just be a piece of cardboard where the touch screen or the touches are detected by the wristband, plus maybe even with the help of cameras, just like a bit more low power. And the display, like what's shown, is just overlaid on the cardboard. So all you get is like the cardboard is just there for the tactile feedback. But all the interaction and the display, that's all rendered on the headset and detected by the wristband. So uh, I think that the future will include ideally these situations where both with the wristband and cameras you can track when and where you've touched things. But because we're a startup, we have to start somewhere, and we don't have infinite money like some other companies in the world. Right now our best first step seems to have been this singular algorithm that can detect this essential gesture very well. So yeah, in case that, hope that makes things a bit more clear, and perhaps that makes sense. Maybe we look back at this and it's all wrong, but right now it seems a lot of evidence points towards it's
Yeah,
not
yeah.
not the worst option. So
But it's like usually once you have the technology, you can pivot from like the way you sell it, but like maybe you can sell it in different ways. But yeah, I think that what you said, that makes sense really, from perspective of like earning on this. And so since we started talking about the customers, like can you like enlighten us a little bit more about basically your like company as a business? It's like how many customers, users, like developers already use your product,
sure, sure.
and then also can we talk about a little bit about like public numbers, like of how much does company cost right now, how many have you
Yes, yes,
raised already? So yeah, to showcase our users, our
totally.
viewers, like yeah,
Of
on
course,
yeah.
of course. Having being founded 4 years ago, we've raised so far 3 rounds. The first round was around 1.5 million. The second round was around the same, and then the third round we haven't published yet, but we that was our latest round. And currently we have around 13 employees spread uh, across Europe. Some in Amsterdam, in Berlin, in Stockholm, but then a lot of us in Finland, Helsinki. We Last year we started making revenue and with these sort of B2B customers. It's been going pretty well. Our investors are pretty happy. And uh, the exact numbers of those, I think a bit at a later point we'll be publishing it. But what is on the consumer side is basically this Wow Mouse app. And by the way, every time I say it, I still feel a little bit embarrassed. It started as a meme or a joke that we'd call it Wow Mouse. But anyway, it's this Wow Mouse app is it was launched around like 2 weeks ago, 3 weeks ago, 3 weeks ago, and now it has around almost 20,000 downloads, and it's basically used by people that that want to try new technology, that want to control their smart home maybe with a mouse, that want to control TV with a mouse, because otherwise what else would you use to control the TV if your remote is not around? And um, and yeah, so people are just tinkering and playing around with it. Um, and yeah, we're getting a lot of it's funny, it's we because we're a B2B company, we really weren't expecting uh, uh, such a sort of 20,000 people to use an app that we actually just put together the apps a couple weeks before we went to CES, and so our Discord and everything had like alarms for unusual joining activity and things like that, and then we were kind of under resourced for that. So 20,000 is sort of a lot for us for a B2B company and a startup at this stage, but yeah, it's been fun. So that's that. Other numbers. Other numbers. Yeah, well, I think those are probably the main ones. Um, Partnerships and other sort of companies, clients that we work with. Like once we have made more progress with them, I think we'll start, uh, you know, uh, doing a few press releases about them. But right now, they're still, sadly, they don't want us to talk about it as much as I'd like to.
Yeah, cool. Thanks for sharing. And can we talk about a little bit the competitor side, like who are your like main competitors and who are you trying to like, because like there is like also technology wise competition probably, and also in terms of like big companies who are basically trying to, like Apple for example, who are like building the
Of course.
headset with like its own way of approaching the touching and like the
Yes, yes, yes.
manipulating. Yeah.
Okay, three types of competitors we have. So I think that as a like the biggest threat probably is uh, if hand tracking becomes somehow uh, really good and really low power. Uh, then you can have one camera. Imagine, so this is previously unheard of, but like one camera that can detect uh, this sort of pinch gesture while not consuming barely any current or energy from the headset. Um, so a lot of there's some good hand tracking companies and hand tracking projects going on, but it's still not quite there yet. And our hypothesis is that hand tracking can't. Like it's just inherently such a hard problem for hand track for cameras and inefficient just from a physics point of view to like video your entire environment at like extremely high resolution compared to an IMU, and then do fucking computer vision on it with deep learning just to detect this. I mean, come on, like that's just like it like to detect everything else. It might be good, like the whole pose of the hand. Maybe that's very good. It the position of the hand, very good. But just to detect this, yeah, just I don't know. It's a waste of electrons moving around. Uh, but no, I exaggerate a bit. But that's basically that's our sentiment. So this is definitely like I'm sure someone could probably figure this out. But and even if they just get there step by step, they may be a worthy competitor to us. So yeah, that's that. But then second category is other wristbands that are trying to detect this gesture. There are some wristbands that use custom sensors, not smartwatch sensors, that are, for example, EMG, or other wrist-based sensors that can detect this and are trying to do it more accurately than we can. Uh, and there's varying successes there. But the problem with that is that they need to use custom hardware, and we're just a software update. Um, so, and then the last category is actually there are a handful, maybe even less, of companies trying to do this gesture just with like the same way we are. They're playing the exact same game. So Apple has double tap, that they, you raise your hand, you can double tap on a smartwatch, on their Apple Watch, and answer a phone call, which is great. This is actually, it's great. It hasn't been designed for AR input, so the latency is pretty low, and the you have to tap pretty hard, and it's sort of for AR, it's just not as good of an experience. But that's because it wasn't designed for it. But I'm sure that a lot of like in the team internally, they're working on it. Um, so yeah, that's how I would split it. One, hand tracking. Two, other wristbands, and three, this exact same thing we're doing, but they're trying to do it better. So
Yeah, great. And so let's also like I'm really wondering. You were talking already about that you like first probably the investor feedback was like from your real close connection, and I'm wondering like what was like your first investor like funding raising, how it was, um, and yeah, like can you talk about this a little bit more? Like how did you the fund?
sure, sure.
Have you made the first fundraising and yeah.
Of course. So first of all, I think Otto has done an amazing job at this. He probably he could tell you a lot about it. And so anything I say is probably you'll look at it and be like, oh, such depth is missing. But what I do know, nevertheless, is that our first investors were, well, it was partially VC, partially angels. The VCs were Superhero Capital from Finland and Super Angel. It's a coincidence they're both called Super, but Super Angel is from Estonia. And we got to know them. I know that the way that we talked to them was also through an advisor of ours that came on board very early on. So Markku Mäkeläinen, who was ex-Facebook and but also an investor and had worked on startups before, serial entrepreneur at this point. He was actually the person that saw our prototype and was like, "Hey, there's this other company that's been doing this. They just sold to Meta for 500,000 or a billion, and yeah, this could be something." And we raised the round with his help. So I think it would have been much harder to do it without him. And I think Otto would agree with that as well. But definitely Otto was critical there. It was a lot of I think I hear a lot of people joined because like in the end it wasn't really like, oh, we had a great patent portfolio and we were seasoned experts in the field, so they invested in us. But they invested in us because of a lot because of yeah, just the team and the people, and that we can figure it out. So I think that was the sentiment.
Yeah, I imagine that it's like really hard to really proceed without investments in like hardware space, right? Because like you need to basically interact with a lot of like to buy basically this hardware, right? The AR VR devices and then the smartwatches like for you specifically. So I imagine that it really helped to for you for your company to really progress in that, or uh,
I think
yeah.
actually the initial, yes, so the initial reason was that we did have one or two patents we wanted to file. That was based on like how to use sensors to detect interactions, or how to use specific sensors to detect specific interactions. And yeah, we were just students. We had no money for that. It was like 20,000 for a patent, and then we realized that also this is a very timely challenge. Like now, right, for the next couple of years, there's a certain time window in which these interactions are being defined for augmented reality, and it would have been hard for us to make this window and make it in this window without external funding. So yeah, if that makes sense.
Yep, makes sense. I'm curious, Jamin, on the amount. Um, like, imagine I'm starting startup. I know there will be X amount of cost and potentially just like baseline salary to ensure I can pay for my rent and food. How do you actually calculate the amount that you're gonna raise? Because I just Googled how much DoublePoint raised. So, and you also said you've in total raised officially 3 million euros. How did you come up with this number? Like, why
That
do
is
you need?
totally. I think if I say anything now, it's just pulling it out of my ass. So I would totally ask Otto about it. Uh, but uh, but no, of course we've had discussions about this and with our advisors. But I would I would want author here if that's okay. This
Oh yeah.
is what I can say, or what I can say for sure is that I think it has somewhat been able to hire the right amount of people and the right type of people to sustain this level of progress. We could have raised a bit more if we wanted to go a bit faster, but I'm not sure if that was needed or not.
Hmm.
But yes, I also I remember it wasn't obvious that our first round was going to be 1.5 million. It may have been less or may have been more, but we like it was an ongoing conversation between Otto and Marco basically. So yeah.
Isn't like universal rule is just the more the better. It's like
That could be part of it. I'm sure that phrase had been somehow mentioned at some point during our fundraising process, but yeah. And also I also think maybe one thing that is a factor here, we have been lucky enough to raise at good times where we haven't really needed the money, so we've been able to negotiate it pretty well, I think. So yeah, like even this patent thing, like technically we didn't really need to apply for those patents. We probably could have done something without it, but yeah, it was so. For example, I'm sure that a lot of startups, of course, the first thing to do is consider bootstrapping. But I think it was the patents and the we realized we need to make some hardware prototypes. Like even though right now we're making software. At that point, we weren't extremely sort of clear on that. And even if we needed to make good software, we needed good hardware so that the sensors could, like we had good sensor streams coming in. So.
Okay, yeah, that was my question actually, because I think I missed this, like to what extent are you a hardware company, and because
Yes.
you're using the hardware from like from Google or other companies, and
Yes.
it seems like it's somehow limiting your ability like to do something, I don't know. And to what extent
Yes,
are you investing in hardware at this moment from the money that you raised?
Yeah, totally. So actually, most of our budget goes into machine learning, but a significant portion does go into just making basically custom versions of smartwatches where we have full root access to, because we don't have root access with like Apple Watch and Samsung Galaxy Watch. So we can't actually make the most out of the sensors that are there. So yeah, we have a lot of internal hardware prototypes, even though we're licensing algorithms. So
Cool. Makes sense, Jamin. I think we can shift back gears to more of a technical conversation, and even like more like let's do some sort of sci-fi type of exercise where we imagine the world in 20 years. I think you are the first guest in our podcast who is more hardware oriented, or like thinking a lot about like human computing interfaces and how it will be. Let's just, for our guests, I think I would personally be a guest, a listener, because both Saddam and Ralm has some sort of VR, AR experiences too, which seems to be the way future of computing, human-computer interfaces would go. And I'm just curious how three of you think about human computing interface of the future, and what are some frameworks of thinking when we want to systematically live in the future and see the future.
yeah, I'd love to I'd love to hear Saddam and wait, actually your name is, yes, Galim, and is Kenshitayev or Kenshitayev.
Yeah, that's right.
Right. Galim, yes, I'd love to hear your opinions on this, both of you.
Yeah, like who does want to start? Like I thought like maybe I'll give a word to Jamin first, but yeah, I
don't want to bias you guys or anything. I want to hear. I want you guys to go first, if that's okay.
like I would say that I'm not like the expert in this matter, or anything like that. But yeah, as Norpreet mentioned, we've had a little bit like experience around VR, specifically me and Polygalum on the AR side. So I think we kind of had these discussions like with I think Norpees and Gallum like off the podcast, just talking about sort of where this could lead, and I think like there was also like really a lot of discussions around the metaverse and stuff, and so like it seems like in this bubble of like people who are around metaverse and like working on this area, it seems like the North Star is to like from hardware's perspective to um, decrease basically the size of the devices, right? Because right now they're like a little bit huge and have a lot of like technical limitations. And as you've mentioned before, like it has like problems with battery, and of course like computational power is not that great yet. And for maybe that's like also the reason that the prices are like not that really acceptable. But so I think like that's North Star like for the people that are in this area, at least from my perspective, that as I've seen it, right? And and so like yeah, my point here is that probably with all of this like development even of like, because as you mentioned, we have a lot to as maybe as a society to agree what will be our next like interaction sort of interaction points with this new basic computational devices. But I would say like if we have as that much of improvement on the hardware itself, it will be much more understandable. You know, like we can easily understand like how what would be the best way. And and yeah, so like yeah, I'm also want to hear like what do you guys think like in terms of like the future of computational power, like how would we use these devices?
So are you saying, yes, so to summarize, are you saying that depending on what form factor the headset can take in the future, that may heavily define the interactions possible? Is that one thing
Yeah,
you're saying?
and also like I think personally that we will reach it, right? But then also the matter like the question is also how soon, and and yeah, again in which form it will be just glasses, or will it be more of I don't know, in different form, like if there will be another like device being developed in any other form that will maybe define how do we basically approach the all this interaction with it, right? So
Right, right. Yeah, yeah. So I think a lot of the times we've had to think about it from that point of view. Like, what is realistic to expect to be put on a headset, and what can be tracked with it. Yeah, I think that's definitely one way, because like no matter what we do with our wristband, that there's gonna be something on the headset anyway. So it's probably gonna be able to do something. Like a lot of our like I'm sure there's a group of people working on these headsets that are actually specifically trying to make the headset itself do everything, so that you don't need a wristband, you don't need I don't know, gloves or rings or even thimbles. Like thimbles are like, you know, like finger caps that you put on your fingertips so they can detect everything. So there's a camp of people that just want to fit everything in the headset. I can see the allure of that. I can see uh, why that's important, and so that's why, like, when we design our interactions, we need to think from their perspective. You know, what would be the ideal interactions that they could achieve with just the headset alone, and and so yeah, we've been thinking about that a little bit as well. So yeah, good point.
Uh, Yeah, I think like if we talk about like in 20 years, I think the glasses
Yeah.
is really achievable. Like having
Mm.
glasses, like a regular glasses, but with AR, like where it's
Mm.
really where they like interface really augments the reality. And
Yeah.
I also agree with that. It's probably gonna be some kind of wearables on the head on the hands or something to track the gestures and etc. I really think, as I said before, that the user interfaces are going to be much simpler. So you don't have to learn a lot of stuff like how to interact with the interfaces, because like when we really moved from the from mouse to screens, it was really simplifying a lot of things that you don't have to you have swipes and you have like these kind of gestures to resize and etc. And I think for like the next computing will be in user interface will be much more simpler, and I think there will be a lot of gestures again, as we're talking about gestures, and I hope there will be a lot of research and it will be really intuitive, that like you can give it to child and it will be really easy to learn how to work with it. Yeah, I think also the cloud computing will be much faster and will be used everywhere. I hope so. That if we are limited, like with the size, a lot of things will be delegated to like cloud computing.
Totally.
And the
Totally.
internet will be
Yeah.
much faster, and yeah, that's my view.
Yeah, I was just I literally had I was just talking to the team. We had a team dinner a couple of days ago, and I was just saying that like no matter how good, how efficient we make glasses, the performance is always going to be worse than if you have glasses than if you compare it with glasses that's wirelessly connected to some computing unit somewhere. It's just yes. And so I do think it's inevitable that there will be this. It'll be a sort of wireless link. The computer is doing something somewhere else because there's really no reason to need the computing to be on your face. It's just yes, I see no reason, but there's absolutely reason. Like the only thing that needs to be on your face really is the interface to your bodily senses, which is that are on your face, which is the eyes and the ears. Like that is what needs to be on your face. But the computing, of course, doesn't need to be. So
I imagine like even now, like in workspaces, there could be some kind of machines that act as like a cloud server which computes a lot of stuff, and you can still wear like glasses and like some watches, but this like it acts like a Wi-Fi router or something. It computes a lot of stuff, and it has very fast, like without delays and stuff. So I think it could be achievable in the near future.
Yeah, totally. I do, of course, like I wish that I could be a bit more quantitative about this and say like, okay, how much, like, what's the data rate that needs to travel between the headset and like that server, right? And also how near does it need to be, and what's the like, could it just be like, could it be a phone in your pocket? Like, it could just be, phones could. I could imagine that the reason phones will not go anywhere in the future, like will not disappear in the future, is because it will still be used to do the computation that's needed on the headset, for example. I can see it. So we'll never get rid of phones. I can see that actually happening. That we'll just always have phones, like a mobile compute unit. But then maybe not. Maybe maybe we'll get to a point where like there's enough base stations, 5G, 6G, whatever, that can do all that stuff without us needing to carry phones around. That's also possible. But definitely, I can't imagine the standalone headset just with the. Yeah, that's a bit.
Yeah, but I really want to challenge that. Like, let's say, if we have, as you said, this cloud computing. Let's say you have like these classes, but everything to compute will be like on your cloud, right, or like on your laptop at home. I don't know, and if those will be with AR interfaces, right? So like you will see basically everything in front of you.
Yes.
Like basically, if one of the screens would be just your phone, like well, how does it like different? And if your, let's say, your startup will implement some of the interactions easier than just opening, like taking your phone from your pocket and doing scrolling or stuff, like if you can just see it and doing stuff with just your one or two fingers, like that would be really easier, right? Even the what we have already, like with mobiles, like
Right. So are you saying, wait, are you saying that we might not necessarily have computing on the headset, or that we might not, or that we, yeah, could you reiterate, like, what were you challenging specifically? I'd love to hear.
yeah. So you were saying that we will always have the mobiles.
Right, right.
Yeah, I was like challenging. What if we replace basically mobiles at all with this, like with glasses, right?
Right. I guess what I meant to say was that even if we do have glasses and we can literally see even a virtual version of our phone in front of us, that the compute itself, like we can fit much more compute in a phone, so the phone can sit in the pocket while it's doing the compute. But we would actually not need to pick it out to use it, but that we could use, like, we don't really use the phone the way we use now. We just borrow its compute. So I think that's what I was. Um, yeah, it could. I could also see though that maybe the analog touchscreen on this, or not analog, well, digital. Well, the touchscreen on this is still pretty good. I mean, it's I guess so. Maybe it could be used for something, like as an input to the headset. But like a block of silicon in your pocket, I think is probably going to still be there. That's what I'm trying to say.
Yeah, but that would be really like strange. Right? Like you're always taking it with you, but don't really use physically.
Yeah, it could be. Yeah, of course, it could be a. Yeah, yeah, that could be just a thing that either happens or it might be weird. I don't know. I think it. I don't know enough about the wireless transmission, like, possibilities here. Um, but I think I read somewhere about, like, or either I read somewhere or something tells me that it's important for the compute unit to be close to the headset. Uh, if anything, it's to reduce power or to maintain high bandwidth. But yeah, and perhaps what's critically important here is that the headset, like, the amount that the compute is offloaded needs to be, like, it's super important that the amount that is offloaded is much larger than the amount that's needed to wirelessly transmit, video feed to that server, because we're going to need the cameras are on the headset, which needs to be, the camera feed needs to be sent to the server, and then the display and what is rendered needs to be transmitted from the server to the headset, and so this bandwidth, like, that the energy that it takes to maintain this wireless connection needs to be significantly less than the energy of the compute itself. So it's not obvious to me yet like, I don't have data on that. I can't, like, I wish I did, so that I could be more confident with this. But yeah.
The way I'm thinking about like the future of computing, if we just step back about like technologies and stuff, I'm just thinking
Yeah.
about the things that won't really change in 20 years. And I think certain desires of human beings that will still be there, and certain biology. So I think like the senses will always be there, right? Like one thing that
100%.
you are talking right now, your company is aiming is more on the touch side, right? And then there is senses of like visual, seeing stuff, right? And then there will be hearing and somehow sound, saying something, right? And then the last sense is also smell. I have never seen any computing still that would actually address that sense.
Right.
Yeah, but like I feel like since all of these senses are there, and the other thing that, in my opinion, will never change, and it will just progress, it's AI, and the way we interact with AIs right now and potentially AGIs in near future. I'm a firm believer that there will be multitask almost human-like AIs near us. So there needs to be some way of interaction with them. And there are two interesting hardware startups that were started by ex-Apple employees. One is AI Pin, and then the other one is like different employees too, Rabbit. This is like small handset, or like one is like actual pin that is controlled by voice, right? Like to be honest, I'm a bit skeptical about the voice control, just because the latency is significantly larger, right?
Let's talk about it.
Than visual way of computing, and like touch. I feel like these two are much faster and can be applied in significantly more situations. However, I feel like voice is still not cracked. Alexa somehow cracked some portion of it, and people are able to just put a microphone. However, Siri or some other things didn't really do it. And like there is stories over there that I have Meta Ray-Bans, and they have Meta AI there too. And I feel like right now with Llama 2 or like GPT-4, the answers are pretty good. Like, you know, especially when I'm walking, I sometimes ask questions and being like, how much it will take X, Y, and Z, right? Like, however, I feel like still the way I will interact the most will be visually and potentially involving some sort of hands, like doing something, right? And for that reason, I feel like eyes interaction will be there. It might be glasses. In my opinion, it might be something else too. Potentially, I personally really don't like wearing glasses, and I don't wear it. And I've seen a startup that has some sort of screen for the lenses. That might be a thing, but then it will be intrusive. I feel like a lot of people don't really like intrusive things. So I feel like it will be a thing that is adjusted to the body. I'm not sure the extent to which it will be injecting some sort of pin into our human-computer interface, right? What Neuralink is trying, and Elon Musk's company that you mentioned in the beginning, which is why I feel like non-intrusive, involving our senses in a way that potentially the senses that are the lowest latency will be used the most. However, I feel like voice will come a lot. And the last non-changing thing would be AI. And how are we going to integrate with AI? Will it be some sort of entity that we are going to see? Or will it be just a background noise, like our thoughts? Basically, I to be honest don't know what is the meaning of AI. Or is it actually a hardware, a human-like humanoid or something? Yeah.
Yeah, it's great topics. I think one thing that I was going to mention, which is now really relevant thanks to you bringing it up, is that there seems to be two different ways of interacting with things, or like there's the interacting where like your mental model is either you're interacting with things or you're interacting with people. So there's like two very different creatures. This thing. If I was the only person in the world, and I had no like, or if living organisms evolved, like there was only one ever living organism, they would never have to like interact with other living organisms. Just interact with things based on tools and physics and sort of manipulating things and the world around them, like you know, moving things around with their limbs or causing chemical reactions to happen, and like this is very like this is what human tool making has sort of taken to the extreme, where we sort of treat the world as an extension of our body, and then we can build basically extra functionality into our physical self. So that is like the tool mental model that we've become good at doing, and that doesn't require any knowledge or any even concept of other people. And the reason why other people is important is because the moment you talk to, like you interact with another person, you basically you have this other basically a copy of you now that exists. Something that basically can understand what you say if you sort of just speak enough of it, or if you sort of communicate with your body language. But the way that you interact and make like by interact, it's sort of by interact I mean like affect the world around you or affect this person. The way you affect this person is totally different from moving things around. You got to use voice, you got to use tone, they've got to understand where you're coming from, the empathy. Actually, human to human interaction isn't even like fully figured out right now. Like it's pretty recent that we've started talking to each other, and like we still miscommunicate all the time, right? So whereas when I want to do something really precise with a tool, I can get it done very consistently. Like so I guess my point here is that there's two mental models that humans have developed, I believe, in how to interact with the world. One is with tools and that are not conscious, and then the other is with like other similar conscious people, and we're used to that, and they both have pros and cons, and in the end, whatever makes the best interaction comes down to how well we can design interfaces to fit these two mental models. So, for example, I think one of the reasons why Siri never really became the dominant way of interacting with things, even though it's been there for a while, is because for us to be able to interact with Siri, our mental model expects that Siri is basically a conscious human being. And it's very hard for Siri to pretend to be a conscious human being because there's so much. That's artificial general intelligence, right? And even Rabbit and the AI pin as well, even like Llama, or ChatGPT, the way we interact with it, our mental model is it's another human being, and so we expect everything that a human being can do, and that's our mental model. And if it can't do that, it's a bad experience. So yeah, that's basically that. But in the end, the ideal case is, like the movie Her. I think was a great movie to portray that if AI, artificial general intelligence, gets to a point where it fits our mental model of another human being, then it could be the main way we interact with everything. In Her, like they don't use computers anymore; they just talk to an AI. It could totally happen. But I think it's probably a while away, like maybe 10, 20 years. I don't know. Some even like professionals, like in the field, say artificial intelligence could come like any moment or like in 100 years, right? So, but then in the meantime, what we do know is that we can still make tools. Like we can still make tools with AR and with our senses. You can still touch things, make things happen, and so I think that's what most of AR has been so far. With Ray-Ban stories too, with Meta AI, they're trying to sort of combine both a little bit. But I think for the most part, our experience as humans has been two distinct ways of interacting with the world. One is through tools, one is through people, and yes, that's the way that I think about it. So basically, all the things that you've been saying, is this is how I've at least organized it in my head. So.
Yeah, I think that's really great like approach, like because I didn't really think about it in that way, like because we as people really differentiate actually the interactions with tools and with real human beings. Yeah.
And sometimes you prefer to get a job done, or you prefer you prefer one mode over the other. I don't really, I guess, like I can't ask another person to play my musical instrument for me. Like it has to be me. I have to be personally expressing through the musical instrument. But maybe to tell me a story is a completely human thing, right? That's very much a human thing that you like. If you want an experience to be sort of curated for you, maybe it's a very human interaction. So you would ask, the rabbit to do it for you. But yeah. So there are, I think it's not obvious that one will be the major tool, major method. So.
And I'm also wondering if those two will actually merge. Let's imagine that any tool you'll be able to intrude with AGI and talk to asks, right? So like you will be able to refer to everything like to human being. That's like
it's like, what is it, Clippy, like the Microsoft Word Clippy thing. Yeah, Clippy. Anyway, it's like that, but for everything, maybe. And maybe for some tools, we'll find that actually it doesn't need to be that artificially generally intelligent. Like it could be very simple, and it'll do a great job, maybe. So there could be a gradual introduction to different tools, or a gradual introduction of AI to different tools, maybe.
Yeah. So I think that's really great topic for discussion, and we can continue for long. But yeah, I think we've
Right. What time is it?
yeah, we made a couple of great
Oh, right. Wow. Time was.
outcomes already, so we can at least wrap up the sci-fi part. And
Sure.
usually we end up our episodes with some of the advice from the guest. So that can be like anything that you really maybe learned yourself throughout your life, or anything that you feel like people are not paying attention to, or like yeah, something like that, that you can really refer to our maybe younger or like any other viewers. So yeah, please share your advice.
Uh, I'm not sure. Of course, like, so two first things that popped to mind, which I wish I could have told myself, is to meditate and read. So meditation, not even like becoming a monk or anything, but just like sitting and focusing on your breath for like 20 minutes or 10 minutes a day. I still don't like consistently do it, but it just feels right after I do it consistently for a while. And also reading. It's really funny. I've always wanted to read for a while, but I never really was a kind of reading guy. I felt like, books are a little bit. I don't know when do I find time to read the books, but I like consistently. I found time finally, but just like every time I go into public transport, instead of doom scrolling, I just have a I have a I buy books that specifically fit in my jacket pocket so that I can bring it out. I don't need to charge the book. I could write notes in the book. I can share the book with friends that can read my notes that have been in the book, and a lot of the times it's nonfiction, and it feels like a conversation with people that you really respect, even though it's just one way technically. But it's yeah. I wish I would have made this habit a bit earlier. But yes. Other than that, probably just I don't know what's worked for me is just thinking about things from yeah this uh, like philosophizing enough, and maybe not too much, but philosophizing enough, and thinking about like why are things the way they are, and what should they be, and then like this thinking about mental models for interaction. Do they have to be this way? And like that has always been a good use of time for me at least. And reading books helps. Sometimes you find a book that answers all of your philosophizing questions. And
And you also talked about the YouTube shows. Like, can you share some of the which really impacted your
sure.
vision or yeah?
Okay. Oh my God. Okay, a few of my favorite ones. I do really like the Lex Friedman podcast. Um, I I have watched I think pretty much every three blue one brown video on maths and physics. It's I think mainly he does maths, but that's really where you get into the deep whys of like why is e to the power of pi I negative one or something like that. Yeah, I would say these guys are great. Um, yeah.
Cool. Thanks for sharing. I think like yeah,
Cool.
I will probably have a look at some of those episodes of those. But yeah,
Yeah.
I think yeah, I think we can wrap up with our episode. Yeah, thanks, Jamin, really for coming to our episode in remote format. I think that was really interesting episode to discuss about the technology from philosophy perspective, to talk about really sort of how you approach things in your startup, and how like in general uh, this sort of sphere of technology will evolve in the future. So yeah, thanks really for coming. and hope we'll have like a lot of success with your startup, and you like a lot of people will benefit, and the society will benefit from it. Thanks to all our viewers. Really leave a lot of comments and likes on our episode, and we will share the contacts of Jamin, so maybe
definitely
feel free
Go
to
ahead.
maybe follow him and also ask him any questions. But thanks everyone for watching. That was like
Of course.
the episode of Real Qadam.
Yeah.
So
And nice to meet you all. And I'm really curious to talk to you and get to know you even more after this. So yes, and anyone also feel free to reach out on LinkedIn and Twitter or even email, and happy to chat.
cool. Thanks everyone then. Bye bye.
Bye.
Great. Bye.